All right, hello everyone, this is Mr. Courage. I'm going to give you some help on some of these problems that we did in class today. First one we did on our own was problem number 3. So we're going to graph this sine function right here, and it says y is equal to 6 sine of 60 degrees. Now if we graph sine function on here, and we type in sine of x, and we hit graph, it's this graph that goes up and down like the sine values around the unit circle. However, it's going to be shifted around because of some of these numbers right here. So we want to get a version of this on paper. Well, what we did in class is we talked about this critical point chart right here of the key points of the graph. So I'm going to go ahead and make a chart right here for number 3. And let's see here. I'm going to need 5 points. And those are my critical points. And the points we're going to use are the mid, max, mid, min, mid, and that's what sine does. If you take a look at this sine wave right here, if I look at one wave of sine, what you see is sine is starting here in the middle, going up to the maximum, to the middle, down here, and these are the 5 points that we're going to plot of our graph. We have 3 of them that are in the middle, 1 that's at the max, and 1 that's at the minimum, and these 5 points right here will give us our graph. So we're going to plot those. Well, we have the equation y is equal to 6 sine of 60x. And it's been changed. It's been changed from here. So it's been changed with this value. And it's been changed with this value. And the letters are A and B. We will refer back to this form of the graph later. But we have these 2 changes to make. We have a change here and a change here. Well, we're going to start with this inside change first, inside the parentheses. And what this change does is it changes it by taking the 360 and dividing it by 60, or 6. So this period length from top to bottom is now 6. And if you've forgotten that, you can just look back to this and say we have a b value, and 2 pi divided by b is, in this case, we're in degrees, 360 divided by 60 is 6. And now we can set up the middles, and the middles are, the middle here is 3, then 1.5, then 4.5. And the maximums over here for the y is always 0, 1, 0, negative 1, 0. That's what sine does. That's the pattern that sine takes around the unit circle. So now we have our inputs and outputs, but we haven't dealt with this 6 yet. We've dealt with this inside the parentheses. Now this just means I multiply this by 6. So all of these get times by 6. And if I times them by 6, that's what I'm dealing with right there. So what I like to do on here is, now that I have my table, now I just make my graph. All right, so let's go to the graph. And let's see here. We have to plot the midline, which would be at 0. So I take my ruler and I come right here at 0, and I draw this line it up, draw it nice and straight, and that is the middle of my graph. Now the maximum goes up to 6 and down to 6. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, negative 6. And I usually just put dotted lines for these ones. Oops. And that's my maximum. And I'm going to come down here, and for this one, I will do the same thing. And that's my minimum graph. And now I just need to plot the points on here, and I have to keep them between the max and the min. And one sine wave, this up and down is going to be to 6. So whereas 6, well, this graph's already scaled for you, so you can't change that. And I think it counts by 4s, 4, 8, 12, 16, 20, 24, 28, 32, 36. So you can't change that because it's part of the graph. And what I know is that from 0 to 6, I have an entire wave. So 6 is here. So sine goes up and down till this point. And sometimes I'll even draw this dashed line with my pencil right here so I know where the end is. And I need to go up and down I need to squeeze all of this in here. And the easiest way to do that is just to say, look, I have three middles, so middle, 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 and it's going to go to the max between these two and the minimum between those two. And there's our graph. And again, I'm going to go over it in blue just so we see what's going on here. We have that same graph right there. Now, we have lots of room here, so we're going to just continue this pattern. And if this is 6, if I go another wave, would be 6 more, that would be at 12. So I'm going to do the same pattern, and watch how quick we can do it. Here's a point, point, up, down to 6. And then if I go 6 more, I'd be at 18, which would be right there. I always just do those 3 points and go up, down to there. And then 6 more would be at 24. And I would do the middle and I'd go up and down. It doesn't have to be perfect, but you want to get the idea. And then even going backwards. This would be -4, this would be -6. So I would go middle, down and up and down. And that's the pattern of sine. Up and down, and you can see how it rotates. Here's a blue section, there's an orange section. Then it goes blue section, then it goes orange section. All the way down until you run out of room. All right, let's do a couple more charts. If I flip over to the back, another sine function is here, number 4. Again, on number 4, I'm going to do my same critical points, x, y, and it's always mid, max, mid, minimum, mid, 0, 0, 1, 0, -1, 0. That's what sine does. Sine does that. All right, but what about the values here? Well, work on the inside. The inside says take that period, divide it by 360. So it doesn't go to 360. 360 divided by 30 would be 18. This would be 9, 4.5, 13.5. Multiply them all by -5. That's 0, -5, 0, 5, and 0. And add 1 to them all. 1, 1, 1, 1, 1. Now we have a problem here though. Look what happened. Our min became our max became our mid because of this negative. So this is now the min, this is now the max. And what that means is when you graph it, sine usually goes up and down, right? Sine goes up then down. This graph is going to go down then up. It's going to be the complete reverse of it. The mid's still going to stay the same. The mids don't change, but it goes down and up. And there's a great picture of it on the back of the notes right here. One's going up, one's going down. Another chart we have to do, problem number 5. Let's go ahead and put this chart, I'll put this chart on the back here, number 5 for you. All right, we have to graph it. Well, we're going to get our table. Critical points, x, y, 0, 0, 1, 0, -1, 0. Mid, max, mid, minimum, mid. And if you ever forget those, they're right here. It's the path sine takes around the unit circle. And now, so deal with this first. If you forget what that does, it's here. It's a b value. B value is the period. So take 360, divide it by 45, and this is now 8. 8 becomes 4 in the middle, 2, 6. Nice, easy numbers to work with. They're not being multiplied by anything. They're actually being multiplied by 1, so we leave them alone, and we add on 5. 5, 5, 5, 4, 5. Then you'll have that graph there. If you want to see what this graph does, watch what a good picture of the graph. If I have sine of x, it's right there. If I add on 5 to it, watch what happens. Sine x plus 5. We have the same graph up 5, and it's a little bit too high, so watch, I'm going to zoom out a little bit. Zoom out. There's my original graph, and there's the other one, where all of these numbers were moved up 5 spaces, and that's what we did here. We took all of these values, moved them up 5 all the way through. So the graph is just the same, moved up 5. All right, on homework, fit as many waves as you can. This problem, yes, it takes a lot of waves. Some of them you can only get 1, some you can take 2. Try and fit as many of them as you can on the graph. All right, tomorrow we'll talk about the cosine graphs.